Namaskar. The topic of discussion is on giant submarine canyons. Continents and oceans are the two first order relief features of the world. Continents are bordered by the seas and oceans. Beaches form the interface between the land and the water. The coastline is the boundary between continental and oceanic masses. The ocean floor has an uneven topography. The surface beneath the oceanic waters is characterized by a lot of diversified relief features. The structure, configuration and relief features of the oceans also vary from one ocean to the other. On the basis of bathymetric studies, the morphology of ocean basins has been found to include two major parts as continental margins and deep ocean basins. The continental margins encompass the continental shelf and the continental slope. The deep ocean basins encompass the abyssal plains, abyssal hills, oceanic trenches and the mid-oceanic ridges. The continental shelf is the first morphological unit of the oceans located adjacent to the coastline. It is an extension of the land beneath the oceanic waters. The width of the continental shelf ranges from 60 to more than 1500 kilometers. The depth of the water column of this region may go up to 150 meters. At present, continental shelf comprises 6% of the earth's total surface area. 70% of the continental shelves are covered with thick deposits of silt, sand and mud and sediments derived from the land. The continental slope begins at the outer edge of the continental shelf. The topographic slope is much steeper than the shelf. It plunges down to a depth of 4 kilometers. The width may range from 20 to 100 kilometers. The slope may range from 5 degrees to more than 60 degrees. The boundary of the continental shelf on the ocean side is determined by an abrupt change in the slope and a rapid increase in depth. This particular portion is called as the continental shelf break. In this episode, the following aspects are explained: the land beneath the oceans, the submarine canyons, the characteristics of submarine canyons, the origin and types of submarine canyons and the distribution of submarine canyons. Let us see the first one, the land beneath the oceans. New technologies and the development of highly maneuverable submersible crafts have allowed scientists to go down to explore the deep oceans of the world. The continental margin represents the edge of continents under the sea or the ocean. The coastal plain is the first part of the water's edge. It includes the beaches mainly covered by unconsolidated sediments. These are subjected to wave energy that moves these sediments by converging on the headlands. The second one is the inner and outer continental shelf. It is about 70 kilometers wide, bordering the continent topography. It generally resembles that of the coastal plain. It has a gentle slope of about 0.1 degree, that is roughly about 1.9 meters per kilometer. Sediments are transported across this shelf by the oceanic currents. The final part is the deep ocean basin. The schematic profile of an ocean basin shows the following 10 features. Number 1, the submarine volcanoes. Number 2, sea mounts that are isolated submarine hills with steep sides, volcano shaped more than 1 kilometer in relief. Third one is the mid ocean rises and ridges. Then comes the abyssal plains, then comes the knolls or abyssal hills, then comes the oceanic trenches, then comes the island arcs, then comes the oceanic fracture zones in the oceans, which are generally east west oriented. They extend several thousand kilometers across the major oceans. The ninth one is the guyards or flat topped sea mounts. These are eroded sea mounts during exposure at the surface. They are more than 1 kilometer in relief. The last one is the atolls which are present. The continental shelves are very significant zones for human and marine life. These zones are known for their mineral deposits and for the occurrence of oil and natural gas. The continental shelf and slope constitute the continental margins. Submarine canyons are cutting across the continental margins and act as feeders to the deep oceans. Let us see the nature of submarine canyons. The word canyon refers to a long, narrow and deep valley of a major or a very old river. As the name implies, submarine canyons are deep, narrow valleys of the continents extending inside the oceans. In general, a submarine canyon is a steep-sided valley under the sea of the continental margins. Canyons are long, narrow and deep valleys of major and very old rivers. As the name implies, submarine canyons are deep, narrow valleys of the continents extending inside the oceans. Mostly they form the extensions of the continental river systems at their old stages. Submarine canyons are located on the continental shelves and slopes. They are characterized by steep vertical walls resembling the continental canyons with tributaries entering into it. Due to their existence under oceanic water, these are called as submarine canyons. Some are associated with the mouth of the large rivers and some are not connected with any of these rivers. Canyons cutting the continental slopes have been found at depths greater than 2 kilometers below the sea level. They are formed by powerful turbidity currents, volcanic and earthquake activities. Many submarine canyons continue as submarine channels across continental rise areas and may extend for hundreds of kilometers inside the sea. The submarine canyons serve as major conduits for transporting sediments from the land and the shelf to the deep sea floors. Undersea canyons are prominent erosional features along both the United States Pacific and Atlantic continental margins. Similarly, the distinction between submarine canyons and submarine erosional channels is not straightforward. Thus, alternative terms such as gullies, channels, troughs, trenches, fault valleys and sea valleys have been used for submarine canyons. A submarine canyon may begin as a river pours into the ocean, eroding a channel in the shallow continental shelf, but much of the carving may be done by the torrents of muddy water stirred up by storms, earthquakes or other big events. Submarine canyons also develop along the slopes of many islands. A typical example is the Hawaiian Islands. Smaller erosional features on the continental slope are commonly called gullies. However, there are no straightforward criteria to distinguish canyons from gullies. There are hundreds of submarine canyons existing in the continental shelf and slope regions of many oceans. The depth of these canyons also vary from 600 meters to 3000 meters. The following are the characteristics features of submarine canyons. A typical canyon starts as a steep, narrow gorge cutting across the continental shelf and then extends down the slope to greater depths of over 2000 meters. The walls are generally steep and high in proportion to its width and ranging in age from Mesozoic to Tertiary era. The transverse section is V-shaped and the canyons have widening courses associated with structural features like faults. The longitudinal profiles show steeper gradient at the head and gradually decrease to lower regions without in any case form any types of cliff. The submarine canyons have tributaries which usually begin at the continental slopes and leading into the shelf, forming dendritic pattern. Canyons have rock falls of all degrees of hardness including granitic and quartzite rocks and sedimentary rocks. The canyons are distributed worldwide, occurring near the coast and off the coast and also in the ocean basins. In fact, submarine canyons are an important source of nutrients and sediments in the deep oceans. They are also a major source of pollution. Submarine canyons are also major hotspots of biological production and fisheries catch. Scientists have found abundant life in many of these chasms, from their rims down to the bottoms of their steep cliffs. This abundance may be due to in part to nutrients from the rivers that feed the submarine canyons. Submarine canyons are the most important conduits for funneling sediments from continents to the deep oceans. Submarine canyons, however, are zones of sediment bypassing, and little sediment accumulates in the canyon until it ceases to be an active conduit. Many of the canyons deposit their sediments at the bottom of the continental slopes in the form of a fan like conical structure. These are called as deep sea fans. They are similar to alluvial fans seen along the foothills of mountains where the valley floors deposit their sediments. In many instances, it has been seen that the volume of the fan is greater than the size of the canyon itself. Submarine canyons are found to be the pathways of transport of huge volume of sediments due to their location. The age of submarine canyons are yet another features to be understood. These are inferred by the age of the rocks through which the canyons are cut. It has been observed that most of these submarine canyons cut across the rocks of Cretaceous, Eocene, Miocene, Pliocene and Pleistocene sediments. It is seen in some places cities dumped raw sewage into the submarine canyons, which funneled into the deeper oceanic waters. Much of these sludges may still be residing inside the canyon, making the canyons highly polluted. Let us see the origin and types of submarine canyons. Many mechanisms have been proposed so far for the formation of submarine canyons. Most of them are debated during the early 1940s and the 1950s. There are divergent opinions about the origin of submarine canyons. Majority of them consider that these are the recent age geological features belonging to the Cenozoic era and Quaternary period. The major theories which were put forward to the origin of submarine canyons are the following: the diastrophic theory, subaerial erosion theory, submarine density current theory and turbidity current theory. The diastrophic theory explains the origin due to the tectonic movements of the rocks like faulting, warping and sinking of the sea floor. Tensional forces lead to the formation of faults and graben on the continental margins, lead to the origin of submarine canyons. The troughs of these zones later became submarine canyons. The subaerial erosion theory was put forward on the basis of the resemblance of these canyons to the continental canyons in their shape and depositional patterns. Deep cutting action of rivers forming such features is a normal concept in geomorphology. The submarine density current theory attributes the role of density currents originated in front of the river mouths to form these submarine canyons inside the seas and oceans. The turbidity current theory attributes to the role of currents with fine sediments in creating these erosional canyons. A turbidity current is a mass of water highly charged with materials in solution or in suspension. This flows with turbulent motion down the slope with normal marine waters. Agitation of wave action on the shore is a serious mechanism of erosion. A turbidity current is a current of rapidly moving sediment laden water moving down a slope. A turbidity current moves because it has a higher density and turbidity than the fluid through which it flows. The sediments from the submarine canyon are then deposited on the deep ocean floor. The erosional work repeatedly carried out by these muddy torrents is thought to be a major force in the excavation of submarine canyons. Turbidity currents are dense sediment laden currents which flow downslope when an unstable mass of sediment that has been rapidly deposited on the upper slope fails, perhaps triggered by earthquakes. There is also a spectrum of turbidity current types ranging from muddy water to massive mud flow, and the evidence of both of these can be observed in the deposits associated with submarine canyons and channels. Each submarine canyon has its own geological structure and morphological components in the seas and oceans. The submarine canyons are characterized by a lot of variations in their basement topography, bathymetry, dimension and other ecological properties. Three types of submarine canyons have been identified so far. The first one is fairly small gorges which originate near the edge of continental shelf and run down into the slope. The Oceanographer Canyon of New England shelf is an example for this. It goes up to 20 kilometers inside the edge of the shelf and 150 kilometers inside the sea. The floor has an average gradient of 1 in 23 with a V-shaped cross section. The second one are the canyons of river mouths extending from shelf to slopes. The Congo Canyon is an example for this type. It extends to about 30 kilometers up this estuary of the river Congo. The canyon is V-shaped and can be traced from 200 kilometers and goes up to a depth of 2500 meters. The canyon floors are covered by silt and clay. The third group belong to the submarine canyons having dendritic drainages which are deeply incised into the edges of shelf and slope. The Monterey Canyon of Southern California is a typical example of this type. It extends up to 75 kilometers offshore and the depth is about 3000 meters. The profile is similar to that of Grand Canyon of Colorado. Let us see the types of submarine canyons. On the basis of morphogenetic processes, submarine canyons are classified into glacially eroded canyons and non-glacial canyons. Let us see the distribution of submarine canyons. Submarine canyons exist in almost all the three major oceans. The following are the submarine canyons of the Pacific Ocean: the Bering Canyon, Monterey Canyon, Navarine Canyon, Pribilof Canyon, Scripps Canyon and Zemchuk Canyon. Three of the largest submarine canyons in the world are incised into the Bering Sea. The Zemchuk Canyon has the largest cross section at the shelf break and greatest volume of the incision of slope and shelf. The Bering Canyon, which is farther south in the Bering Sea, is first in length and has a total area of 30,800 square kilometers. In contrast, the largest submarine fans, the Bengal, Indus and Amazon fans, have substantially smaller than this canyon, that is the Bering Canyon. The Bering Canyon is the longest of the Bering Sea canyons. It extends to about 400 kilometers across the Bering shelf and slope. It is confined at its eastern edge by the Aleutian Islands. The width of the canyon at the shelf break is about 65 kilometers. It is about 2/3 in dimension than that of the Zemchuk Canyon and Navarine canyons. Due to its great length, the Bering Canyon has the largest area. At a depth of 3200 meters, the Bering Canyon reaches the Aleutian Basin. Next comes the Monterey Canyon. The Monterey Canyon is the largest and deepest submarine canyon off the Pacific coast of North America. It covers an area of 2380 square kilometers. The canyon has 3 distributaries at its upper reaches in Monterey Bay near California. They are the minor Soquel Canyon to the north, the main Monterey Canyon with its head aligned east west of Moss Landing, the Carmel Canyon to the south. Carmel Canyon is the main tributary of this. It joins with the main canyon at an axial depth of 1800 meters. The sinuous courses of Monterey Canyon goes up to 2900 meters. The Navarine Canyon is a submarine canyon in the Bering Sea. It is just as wide but less than half as deep as the Semzuk Canyon, which is the largest canyon in the world. It is covering an area of 14,600 square kilometers. The Navarine Canyon is the third largest to cut through the Beringian margin. It is the second largest in area. Though these canyons were not directly formed by rivers, it is postulated that when the sea level was low during the ice ages, rivers such as the Yukon and the Kuskokwim may have shaped in part the heads of these canyons. At the shelf break, it is approximately 100 kilometers wide. Pribilof is a long submarine canyon. It is existing in the Bering Sea. It is located southeast of the Pribilof Islands near Alaska. It runs across the edge of continental slope and is 426 kilometers long with its walls 1800 meters high. It is believed to have been formed when large masses of sediments supplied by the Alaskan and Siberian rivers slumped down the slope of this shelf region. Scripps Canyon is a shallow marine canyon in the Pacific off La Jolla in California. The valleys are 12 meters deep. The maximum depth goes up to 300 meters. Due to its shallowness and closer to the Scripps Institution of Oceanography, it has been thoroughly studied. The Semzuk Canyon is a giant underwater canyon located in the middle of the Bering Sea. This submarine canyon is the largest canyon in that ocean. It covers an area of 11,350 square kilometers. The canyon has a vertical relief of 2,600 meters dropping from the shallow shelf of Bering Sea to the depths of Aleutian Basin. Semzuk Canyon is deeper than the Grand Canyon. Semzuk Canyon has 2 main branches, each larger than typical continental margin canyons such as the Monterey Canyon. Let us see the submarine canyons of Atlantic Ocean. The Atlantic Ocean has the following major submarine canyons: the Amazon Canyon, the Hudson Canyon, the Veracruz Canyon, the Congo Canyon and the Great Bahama Canyon. The Amazon Canyon is a submarine canyon within the Amazon fan in the Atlantic Ocean. It is located approximately 322 kilometers from the mouth of the Amazon River near South America. It covers an area of 2250 square kilometers. It was formed in the mid to late Miocene period. The canyon is believed to have formed through mass failures and subsequently evolved through underwater erosion. The Veracruz Canyon is an underwater canyon located off the eastern coast of Mexico in the Gulf of Mexico, not far from the port of Veracruz. It is considered for drilling to obtain oil in and around Veracruz Canyon. Next comes the Congo Canyon. Congo Canyon is a large submarine canyon incised into the South Atlantic continental shelf and slope of the equatorial Africa. The head of the canyon lies 28 kilometers inland up the Congo estuary. It has a depth of 21 meters. The canyon crosses the entire shelf for 85 kilometers offshore. It cuts across the continental slope and goes up to a depth of 2650 meters. Next comes the Great Bahama Canyon. The Great Bahama Canyon is located off the Bahamas in the Atlantic Ocean. It lies northeast of the Great Bahama between Great Abaco and Eleuthera Islands. Two main branches merge to form the Submarine Canyon. The vertical wall of the canyon goes up to 4,285 meters from the canyon bed to the surrounding seabed. It is 225 kilometers in length. Let us see the submarine canyons of Indian Ocean. The Indian Ocean has a few notable submarine canyons. They include the Perth Canyon and the Swatch of No Ground Canyon. The Perth Canyon is a submarine canyon located on the edge of the continental shelf of the coast of Fremantle, Western Australia. It is located at approximately 22 kilometers west of Rottnest Island. It was carved by the Swan River probably before the Tertiary period. It is an average of 1.5 kilometers deep and 15 kilometers across, making it similar in dimension to the Grand Canyon. It occupies an area of 2,900 square kilometers and ranges in depth from 700 to 4,000 meters. Within a few kilometers, its depth drops down to 200 meters down to 1000 meters, and then it continues as a deep gully all the way out to 4000 meters depth. It contains the world's largest plunge pool, a depression in the canyon which is 2 kilometers long, 6 kilometers across and 300 meters deep. The Swatch of No Ground Canyon is a submarine canyon existing in the northern Indian Ocean. It supports a fairly well described group of fauna that includes one of the world's largest known populations of Indo-Pacific bottlenose dolphins, a possibly resident population of Bright's whales and a large group of spinner and pantropical spotted dolphins. The distribution of these species is stratified according to the environmental characteristics, with Bright's whales and bottlenose dolphins concentrated in relatively shallow waters close to the canyon head where upwelling is maximized. Submarine canyons are believed to contain vast reserves of methane hydrates, a promising clean burning natural energy source believed to reside in near freezing temperatures under high pressures within seafloor sediments. Although no technology exists yet to extract the methane from this source, these methane deposits are dispersed under the ocean floor over millions of square miles in this and other areas of the world. Some scientists speculate that the methane gas pockets in the underwater shelves could cause undersea landslides that might also produce tsunamis. Many a time we do not know the origin of tsunamis, but we attribute to the tectonic forces alone. It may be also due to the release of methane from these types of ocean floors, which may also cause tsunamis. Physical and biological processes that are common in submarine canyons are mass wasting, turbidity currents, bottom currents and bioerosion, mass wasting and turbidity currents being the more important out of this. Understanding of submarine canyons gives a lot of scope for marine biological, marine geological, marine chemical investigations and exploring the oceans for future human survival. Thank you.